If you're a DevOps engineer, probably you are required at least once to build a LAMP stack. LAMP stands for Linux, Apache, MySQL and PHP, and that is exactly what we're going to do in this video. Well, some of you may call it as a 3-tier application, but let me clarify something. A 3-tier application is an application that has front-end, back-end and a database separated. Our application is going to be a 2-tier application because the front-end and back-end is going to be in one service. They both are monolithic architecture because of the number of quanta, which is 1, but this separation of front-end and back-end specifies whether it is a 3-tier or 2-tier. Now, 2.5 years ago, when I first started as a cloud engineer, this was my first project. In that time, I didn't have a lot of knowledge of Linux application databases and how to deploy them. And the idea was to deploy it using infrastructure as code on CloudFormation or Terraform. I spent a lot of time, probably 1 month of debugging and building the application. So at the end, I managed to deploy it. And right now we're going to see how I managed to deploy it 2.5 years ago using CloudFormation and Terraform. In case you're lazy, you can directly go to the new architecture overview. There you will see how to deploy it the easiest way possible. Okay, so here we are. Let's see how the architecture looked back then. Yeah, this was my first architecture that I built using Draw.io. And what do we have here? It is an autoscaling group that has the application. Basically what I used was phpmyadmin, which is an PHP application that integrates with MySQL. And I managed to deploy the VPC, subnets and everything, security groups and also the RDAs. And it was only one RDS, not with a second, because it was not multi-easy. And yeah, a lot of mistakes because in here I didn't do a load balancer for databases, but only one load balancer for the applications. And yeah, also the NAT gateway, it was not there. And the internet gateway. So this was the first architecture that I managed to do. Let's see firstly on the Terraform code that I had that time. So on the Terraform project, I had everything on the main.tf. On main.tf, yeah, so most of the things are hard-coded because I was not a very good developer on Terraform back then, and I was still learning. And we have like resources for every component. So I had to manage the building of the VPC, route tables, internet gateway, subnets, and everything that had to do with the network. So public, private subnets, route table, security groups for EC2, security group for application load balancer. And in that time, I used AWS launch configuration. 2.5 years ago, this was the idea to deploy using autoscaling group by using launch configurations. Right now, AWS has deprecated this service, so you need to use a launch template. So I managed just to make a copy of the launch template and made some changes, but this was my initial configuration using launch configuration. So launch template and also the autoscaling group with the load balancer. And also the database instance, which was an RDS MySQL 5.7, the engine version. And yeah, this was probably the architecture using Terraform back then, which still works pretty good, but I'm not going to deploy this one. Now let's see how the CloudFormation looked. So back then I did 2 CloudFormation stacks. One was without SSL for the load balancer, so without HTTPS, and the second was with HTTPS. Let's see the CloudFormation stack. So some parameters, so it can be dynamic. Some of them can be like the key pair for the EC2 instances, the username and password for databases, KMS for the RDS encryption, and also the load balancer listener certificate. And back then I used the OpenSSL to make a new certificate for my endpoint and then import it on the certificate manager on AWS. So same as Terraform, I managed to do the networking part, so VPC, internet gateway, subnets, private, public, so everything is hard-coded. The database, load balancer and also load balancer listener for the HTTPS. So yeah, launch configuration, because I have not changed the CloudFormation stack yet, only the Terraform, just to test it if it works again or not. And let's see the user data. So user data you can specify when you create an instance, or you can specify it on the launch template or launch configuration. What is user data? User data, with another name, it is called Cloud-init. So basically, when you start an instance, you can write commands or you can install packages that you want to be on the new instance. So whenever that new instance spin up, those commands are going to get run automatically. So you do not need to SSH into the instance and then run all of those commands, but you can just specify it on the user data. Basically, to run an application, this is not a very good approach, because running all those commands is not very time efficient, because you need to install every time you spin an instance, you need to download packages and you need to start services. So building an AMI from an already configured service is better than this, because this takes a lot of time to spin up. And the user data was the hardest part for my LAMP stack. Basically, I spent in here like 2 weeks figuring out how to write the commands so it would spin up automatically. The user data on its configuration has the installation of some packages, creating an Apache group, installing phpmyadmin, unzipping all the configuration files, and also in the end I would change some variables such as the connection string, and since we are using CloudFormation or Terraform, it would wait until the database is ready. So it's going to get the endpoint and then it's going to change it to the config.inc.php of the phpmyadmin. So whenever the instance gets spinned up, so it is ready, and you enter the website, it would automatically connect with the database. So no manual intervention with the instances. Fully automated using Terraform and CloudFormation. So security groups and some outputs for the page. So this was the CloudFormation and also the Terraform configuration of how I managed to do 2.5 years ago. Now let's see a new way, a simple way, so you can save time and no operation overhead for deploying this kind of application. The new way to deploy it, we're going to use Docker Compose. phpmyadmin is a free image that you can download from Docker Hub. So you can use phpmyadmin and also the image of MySQL, and using Docker Compose you can compose those two services together, so it's going to connect automatically one with another. This is the Docker Compose YAML file, configuration file. So we have two services, which is the database and phpmyadmin. The database has the image of MySQL, and the container name, it is MySQL database. We have set environment variables for the root password, which is just an example, and for the phpmyadmin, the image, we are going to expose the ports from 80 of the container to 8080 of our host, and we specify the environment that the host that is going to connect is the same as the container of MySQL that we are going to deploy. Let's open the terminal, and on the terminal let's go to Docker Compose and run Docker Compose up on the detached way. So the container is up and running. Let's open Firefox, localhost 8080, and it opens the phpmyadmin. You can also specify this host, which is the MySQL database. Since the two containers have communication with each other, they know the domain of each other. So root is going to be the username, and also the password is going to be example. And this is the LAMP stack. So basically phpmyadmin is the application, frontend and backend together, and the database is connected. So if we want, we can create a new database. So sty and create new table, sty only one ID. Save. So we managed to deploy the LAMP stack using containers. Now this is on the dev environment. It is in our localhost. Right now we are going to see how we can deploy it on the AWS using Fargate, and the database is going to be on the RDS MySQL. Let's stop the containers first. Okay. Now, the architecture. Since the dev works using containers, then we're going to deploy using Fargate. This is the architecture. We are going to deploy a VPC, public subnets, private subnets, knuckles, route tables, internet gateway, so all the components of the network, VPC. The application itself is going to be hosted on Fargate. The database is going to be on the RDS. Our application is going to be fronted using an application load balancer. And this application load balancer, we are going to make the HTTPS listener using one certificate from the certificate manager, which will be validated using the domain of our Route 53. And whenever the users are going to connect with the application load balancer, it's going to load the traffic to one of our Fargate tasks, which is going later to connect with the RDS. So let's see the configurations. I've managed to run some Terraform code. So the network, we're not going to do all the resources one by one. You can also use modules, because modules saves you time. In case you want to learn how to deploy in VPC, then you can do it resource by resource, but I do not care, and I'm going to use modules for that. So the module of the VPC, I specify the name, the CIDR block, the private and public subnets, the availability zones, and I do not want any NAT gateway or VPN gateway, and tags. Now we have the database, Fargate cluster, and also the load balancer. So we are going to need 3 security groups. If we start from the database, then we're going to allow the ingress on 3306, which is the MySQL port, from the security group of the container service Fargate. Then, for the security group of the container service, we're going to allow 80, port 80, since the phpmyadmin works on port 80, from the security group of the load balancer. And also an egress rule that allows all outbound traffic. Then for the load balancer, we are going to allow port 80 and port 443 from anyone in the world. And also the egress is going to be all traffic. Now let's see the database. So the RDS, still a module. I specify the identifier, the engine, the allocated storage, the username and password for that. I specify the security group that I just showed, and the subnet IDs, which is going to be from the module of VPC for the private subnet. And the subnet IDs, which are the private subnets from the VPC that we are going to create. Family is going to be 5.7, and just for simplicity, the deletion protection is false. Now the container service Fargate. So we create a cluster, we create a task definition, the load balancer, the service, and also I will show you later this one. So the task definition, we're going to specify the type of Fargate, and the container definition is going to be some image, which is the phpmyadmin, and CPU and memory, which are as variables, and one environment variable, which is the PMA arbitrary, some port mappings, which is the port 80. I'm going to create a load balancer for that, which is an external load balancer, so everyone can access it, and the type is application. On the public subnet, I specify the security group of it that I just created. We are going to create a target group for all of our Fargate cluster, and the target type is going to be IP, so not instance, because those are not instances. Those are tasks, and all they have is IP. And the listener, which is on the port 80 as HTTP, we're going to create the container service. So basically we're going to use the load balancer that I just showed you on port 80, and the network configuration, we're going to deploy it on the public subnet. You can specify private subnets, but to do that you need to create a NAT gateway on the VPC, because the Fargate service needs to get the image from Docker Hub, and in case it does not have a route to internet, then it's not going to work. It's not going to spin up the tasks and they will be stopped. Now this module right here, it is an HTTPS module for load balancer, application load balancer. Basically I've done this module 1.5 years ago when I needed to make a load balancer using HTTPS, and also to make the certificate from the Route 53, and also to validate the certificate through Route 53. So this module on itself, it just creates the certificate on the certificate manager, which is validation as DNS. It creates the DNS records to validate it, and also a listener on the port 443, which specifies also the certificate and creates a record for the load balancer endpoint on the Route 53. Very handy. So this was the entire of the code on the Terraform. On variables, I've specified some variables such as CPU, memory, image, port, prefix, region, instance, class, and hosted zone. And the auto.tf vars, I've specified just the prefix. We're going to deploy every resource, and I've specified on the auto.tf vars the prefix, which is going to be the first part of every resource that we're going to deploy, and also the hosted zone. So the hosted zone can be changed based on the environment. Right now I'm not going to use my account, I'm going to use a sandbox environment. So let's deploy it. Go to terminal, cd Terraform project, new version, Terraform init. Okay, so let's validate it first. And apply, risk it. So 47 resources to add, and specify yes. We started deploying. So this is going to be ready in 8 minutes, because you're going to deploy an RDS and after that the Fargate cluster, so it takes some time for the database to be up and ready. Terraform finished, so let's see what it did deploy. First of all, we can see that the database is available, the style as the prefix and the db for the suffix. We have the cluster, so we have a style cluster on phpmyadmin, and we have 3 active tasks on it. So all of them are running. And we also can see the load balancer, and it has the port 80 and port 443, which uses the SSL TLS certificate from Route 53. phpmyadmin is up and ready. So what do we need to do is specify the endpoint on the server. The username is as we defined on the Terraform configuration. So it's going to be user, and password is going to be Ronaldo123. And we are inside of phpmyadmin connected with the database. In here you can see that the DemoDB is already created because we specified it on the module, but we also can create another database. So we can do whatever we want. So we deployed an application, which is phpmyadmin, that connects with the database. And this phpmyadmin is front-end and back-end as one, and this is why it's called two-tier application. And there is just a small problem with this type of application, that it cost me like 1 week of troubleshooting. On load balancer, the target group, the attribute. Now, if you do not specify the stickiness session as on, then you are not going to log in to the phpmyadmin login page. I don't know why and how it works, I do not care in fact, but it looked like when you try to log in, if you don't have this sticky session to be managed from the load balancer, then you're not going to log into the database and also to the application itself. So this was a problem that cost me like 1 week. If you know why it works like that and why do I need to activate sticky session, or if it is there some kind of application configuration that I need to specify as environment variables, please let me know in the comments. But for now, the application is running, we can control the database directly from our web application. The database is on a private subnet, so it is secure. It allows inbound traffic only from the Fargate cluster, so no one is allowed to connect with it. So, recap time. We learned what is the difference between a 2-tier application and a 3-tier application. We learned what the LAMP stack is and for what it stands. We learned how we can deploy it using user data on EC2 instances, as I did 2.5 years ago with CloudFormation or Terraform. We also learned the importance of Docker images. Everything that you want to build probably has a Docker image, so stop manually configuring them. You can just take the image and run it, and it removes all the burden of configuring the application. We learned how to deploy this LAMP stack using Terraform, how easy it was to use Fargate service to deploy the image of phpmyadmin connected with the RDS database, and also from it using an application load balancer. So it was easy that even you can do it. Even you don't have any kind of experience, Terraform is there, Docker is there, use them. And as I said in my last video, a good DevOps is someone who automates his work. So you need to stop manually configuring things. You need to use automated ways.